Okay, we are in section 6.3 of Rogawski's book on calculus. This is page 357. This is doing problem 39. So look at the instructions here. Find the volume of the solid obtained by rotating the region enclosed by the graphs about the given axis. Okay, so we've got y equals x squared, y equals 12 minus x equals 0. We're going to rotate about y equals 2, and notice we're only dealing with positive values of x. Okay, let's see if we can put all that together. Let's see. So we have y equals x squared, the old parabola. We have the line y equals 12 minus x. So that has an x-intercept of 12 and somehow comes down that direction. And then we have the line x equals 0. That's this vertical line. So I guess we're kind of concerned about that region in there. We're going to be rotating around the line. Maybe I'll dash the line. This is y equals negative 2. Okay, so here's my region. Notice that cutting perpendicular to the axis of rotation is going to work pretty well. So this is the disk slash washer method, we usually say. Whoops, almost had an accident there. Let's see, so the disk or washer method. Okay, so let's think about, this is what my cut is. Now I'm going to be cutting along the x-axis, right? I'm going to be starting to cut here. I'm going to be finishing cutting where those lines intersect. So starting at 0, finishing wherever those intercept. Now how do I see where 12 minus x and x squared intersect? Well, I better go over here and I better say, hey, where does 12 minus x equal x squared? When they have the same y value, I guess they're intersecting. So let's see what happens. I'll bring this all over to this side. X squared plus x minus 12 equals 0. That factors, let's see, x minus 3, x plus 4, minus 3 and plus 4 multiplied to negative 12. They add to 1. So we've got what we need here. So I guess these two lines cross at x equals 3 and x equals negative 4. Well, this cross is actually somewhere way over here. This is the piece that we worry about. So we're going to stop cutting at 3. Okay, so I'm cutting along the x-axis from 0 to 3. Now, can you see that my cut at a value x, that is going to be my outer radius, I'll say capital R, and my inner radius is right here, I'll say small r. So in general, with the washer method, I think of pi capital R squared minus pi lowercase r squared. And by putting the pi outside, it distributes to both of those pieces. Okay, so pi integrating from 0 to 3 dx. What is that outer radius? Now, I'm sorry here. I should go, my radii, of course, go to the axis of rotation, right? So it starts at the axis of rotation and it goes to the outer edge. So how big is that r? Well, going from r, which is at a height of negative 2, the axis of rotation, up to 0, right? That's a distance of 2. Then how far is it from here up to here? Well, 12 minus x. So somehow or other I get 2 plus 12 minus x. That's what capital R is. We'll square that minus, what's this shorter radius? Well, this piece is 2. What's this piece? Well, that piece is x squared. So 2 plus x squared. Fair enough? Okay, so before we do calculus, before we integrate, we need to beat this with algebra to make it as simple as possible. So integrate from 0 to 3. You could think about this as 14 minus x all squared. 14 times 14 is 196. negative, if you had 14 times negative x, that's negative 14x. I'm going to get two of them, negative 28x plus x squared, then negative x squared. Then here I get minus 4. This piece is squared. That r is squared. So minus 4. Then 2 times the x squared gives me 2x squared. I get 2 of those, so plus 2 times 2, 4x squared. Then x squared times x squared, and again that's subtracted, so we should put a minus sign there, minus x to the 4th. Okay, so we've sort of beaten it nearly as simple as we can. Maybe we should combine like terms before we go onward. Integral from 0 to 3. Let's see, what do we have here? We have 192 if we combine the constants here. We have minus 28x. We have an x squared, and we have a minus 4x squared, so minus 3x squared, and a minus x to the 4th. Right? So now I've combined like terms. Now I'll go ahead and integrate. Let's see, I get pi 192x. That's my kind of integral. Negative 28x. This is going to become x squared. We've got to divide by 2 though, so negative 14x squared. Negative 3x squared integrates to negative x cubed, then negative 1/5 x to the 5th. That's evaluated from 0 to 3. Okay, so we need to plug 3 in there, so it's pi times 192 times 3 minus 14 times 9 minus 27 minus 1/5 times 3 to the 5th minus 0 plugged into all of that, which is conveniently 0. So let's see what we get there. Maybe you could do that by hand, but I think it would be a heck of a lot easier using a calculator. Let's see what we do there. So I get 192 times 3 minus 14 times 9 minus 27 minus 1/5 times 3 to the 5th equals 374.4 pi. And that's the end answer. That's the volume of rotating that area around the axis y equals -2.